All right, this video is going to talk about measures of dispersion or spread in section 3.2 of UMA statistics. So dispersion is just how the data is spread out. So the larger your number, the more spread out it is. Now we're going to look at two sets of data. And these two sets are each going to have 100 points of IQ numbers. And we're going to compare the mean, median, and mode, and then look at the histograms. So if we go to a Google sheet here that I have the data all typed in, we can find things out on our own. Oh, what'd I do? That was supposed to be like a 10, I don't know. There we go. We can type it out all on our own, or we can click on this cell, type the equals button, and for the mean, we're looking for the average. And then in parentheses, we would click on that cell and drag to the end. And here I'm just gonna delete all the things that are being weird. When you do it on a computer, it's much easier to click and drag. But once you do that, it calculates that average for you. Then, if we do our median, so I'm going to click equals, type the word median, put my parentheses there, and then click and drag to get that whole range. Click and drag. See how you do it right this time. Okay, well, it's not dragging, so I'm just going to type because I know it ends in 101. And then mode is the same thing. Equals, type the word mode, and then same thing. On the computer, I often find it's easier to click and drag, but on the spreadsheet, sometimes it's simpler to type when I'm on my iPad here. So mean, median, and mode are calculated there. And then we could do it again on this one, mean, median, and mode. So let's do equals, average, and this time we're in C. So C2 to C101. What the heck? Enter. Okay. Median equals median, parentheses, C2 to C101, enter, and then mode equals mode, enter. So this will calculate all of those for us. Then if we compare the numbers, our mean of data 1 is 100.4, data 2 is 100. Those are pretty close, just off by a few decimal places. Then we've got our medians, they're 4 points off, and our mode is exactly the same. So by measures of center, these things are very similar. If we then look at our histogram, though, we see that it's very different data. A is much more spread out. It has more of a bell curve, whereas University B, it's clustered more in the middle and not as spread out. So this is where those measures of dispersion are nice, because they'll come in and they'll help you see that difference when the center doesn't. So let's go back to our thing over here. Range is one measure of dispersion. It's just the maximum minus the minimum. So you subtract those numbers, that's what you get. Oftentimes it'll be a capital R. You just find the biggest and the smallest, subtract them. Deviation about the mean is also called the standard deviation. This is how it's spread out from the mean. So on that document, University A is much more spread out from the middle out, so that's going to have a higher standard deviation. Population standard deviation is this little sigma, whereas the sample is an S. The equation looks very complicated, but it's not as bad as it looks. So this symbol means the sum. So what we're doing is you're finding every data value minus the mean and squaring it. Then you add those all up, divide by the number, and take the square root. So it's pretty complicated, but we're not going to do it. I'm going to show you how to do it on the calculator. I just wanted you to see what those formulas looked like. And that the difference is here, population deviation uses the population mean, sample deviation uses the sample mean, and degrees of freedom, which we'll talk about in a second. So using this data set, let's find the range. If we go through, our biggest number is 94, and our smallest number is 62. So 94 minus 62 is 32. That's the range. Now, standard deviation, we can do all out, or the calculator will do it for us. So we're going to do what we've been doing, hit stat, which is in this row next to that, hit enter, and type all those numbers in. So we're going to type all those scores in here in L1. Then we're going to hit the stat button again. So pause the video if you need more time to type. Arrow over to calc and choose one variable stats. Now you want your list to be L1 because that's where we just typed them. And we don't have anything else, so leave your frequency list blank and hit enter. Then you're going to get this list of things. So X bar is your mean. SX is the sample deviation, as if this was a sample that you found. And this sigma X is the population. So if we're treating these scores as the population, we would use the 9.81 or 9.82. If we were treating this as a sample from the population, we would use the 10.35. So that gives you that right there. You don't have to find it by hand. You can also do it on the Google Sheet by typing and choosing whether it's population or sample. Because we're using data with samples, we understand that every sample can be different. That's why up here we divide by this n minus 1 instead of n, because we just want to acknowledge the fact that it's a sample. So whenever you're asked degrees of freedom, you take the data points and subtract 1. All right, variance is another type of spread, and it's just the standard deviation squared. So we would take this number and square it if you were asked for the variance. Bell-shaped curves are the ones like this that are symmetrical, and the empirical rule is the rule that for the most part data falls within given percents. So if your curve is truly symmetrical, within 1% of the mean, you have, or within one standard deviation of the mean, you have 68% of the data. Cut that in half, you have 34. Within 2 standard deviations of the mean, you have 95% of the data. Take out those 34s, split what's left in half, you get 13.5. Within 3 standard deviations of the mean, you have 99.7. And then all that's left is 0.3, which gives you these percents. So those percents are a way that we can estimate how many data points or percentages that we would fall within one standard deviation. So let's look at IQ. IQ, we're saying the population mean is 100. Mean IQ is 100, and the standard deviation is 15. So it spreads out like this. 100 in the middle. And then every time we go up, we're going up 15. So 115, 130, 145. And if we go the other way, we're subtracting. So 85, 70, 55. And then those percents are always going to be the ones we use when we're estimating. So we fall right in to here. And then if we're using this rule, we're saying, what percent of people fall between 85 and 130? Well, 85 is here, 130 is here, so we just add the percents. 34 and 34 is 68. 68 and 13.5 is 81.5. So we're saying 81.5% of people fall within this range of IQs. That's how you work with the standard deviation. So that is section 3.2. Let me know if you have any questions.